The worst system monitoring setup I've ever witnessed was in the early 2000s during the dot-com boom. There was this company I was working with, and they needed exactly 3 servers. And they signed a support contract worth the equivalent of $2 million in today's money. It was crazy back then. It's absolutely ridiculous today. And I said to them at the time, and I was only half joking, I'll make you a counteroffer. I will give you the best support you will ever witness. For half that price, for a mere $1 million, I will camp out next to the server rack for the whole year, and I will never leave their side. I will be constantly watching them. And they didn't accept my offer, which is a shame because they went bust a few years later, so I would have been able to leave the room early. Now, while we all contemplate whether that would make an excellent season of Squid Game, we must also contemplate whether the state of the art in system observability has improved since those days. And I hope it has, because I'm certain that the problems got harder. Our expectations for scale and uptime have gone up massively since then, meaning a lot of the systems we build these days are distributed by default, which in turn means we need techniques for building out different components. We start introducing things like microservices to manage the complexity, which in turn opens up building systems with many different languages and different databases. How do you stay on top of all this? How do you make sure it's performing well? And how do you debug things when they go wrong? I'll tell you how you don't do it. You don't do it in an ad hoc way. It's no good having a different monitoring technique for every piece in the system. System observability needs a unified strategy. You've got to shoot for something that's going to work everywhere, on every server, for every component written in every language. And I think that means you have to tackle the problem from the kernel level upwards. And that's where I need an expert. Joining me to discuss the latest in monitoring, profiling, and observability strategies, from the kernel all the way to the dashboard, is Mohammed Aboullaite. He's a backend engineer at Spotify, and he's going to take us through how you can peek into the Linux kernel programmatically with eBPF, how you don't have to because there are several projects that have already done it already, and how you go from there to a complete monitoring picture of your system. We've got a lot to pack in this one. We managed to cover everything from packet filters to cultural changes, all in service of getting a clear view of what happens to your software when it hits production. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Mohammed Aboullaite. And joining me today is Mohammed Aboullaite. How are you doing, Mohammed?
Very good, and good to see you again. It's been quite so long.
It's been a whole week.
Exactly.
We were in Miami. We were supposed to record this under the glamorous Miami sun, and logistics got in the way. So now you're in a particularly glorious office room there with the grey shining back at you, and we'll do the best we can.
Yeah, and thanks for the flexibility. I got the calendar invite wrong, obviously, because of I accepted it when I was in Stockholm, and then with the time zone, I just sorry for that, and thanks for the flexibility and
no problem.
Allowing us to discuss, even if we're.
I'm sure there's a link here between calendar problems and overloading of disparate systems and having to reschedule the long-running processes. I'm going to make that link because we're going to talk about profiling and performance and what to do when your machine gets overloaded. There we go. So you, for context, you work at Spotify and you've worked at some other interesting places. You have done profiling in what we might call the very wild, right?
Yeah, correct.
And I thought my first question is the state of profiling today that there is one universal good answer that works on every operating system, works for every application, and we should start talking about that immediately, whatever it is? Or is it just there is no one-size-fits-all solution and we have to talk about the different approaches?
as anything in software engineering, it depends, right?
Yeah.
And I think when we talk about production and stuff, we generally talk about Linux as the dominant operating system in that sense. So a lot of solutions that I worked with and I worked on are primarily Linux solutions. So if so my experience would be primarily around Linux. I won't be covering obviously Windows because I had no experience whatsoever in deploying applications in Windows servers or using Windows servers. I used it, I think, for a brief period of time, just getting access to it, and that's pretty much it. But my
Fair enough.
experience has been primarily around Linux. Just wanted to get that out of the way and clarify
Okay.
it for you and the audience as well. So universally, I would say I don't know, and that's obviously an accepted answer. Even if a lot of tech folks doesn't want to say I don't know, especially in the age of LLM now. But yeah, I don't know about other operating systems. But yeah, for Linux, we're getting close to it. Because of we're gonna probably dive into it because of eBPF and how it's built into the kernel. So whenever you have an operating Linux kernel, I think with a specific version kernel that it should be now widely supported, eBPF can be there. And then there's a lot of tools that are built on top of eBPF for profiling.
Okay. We are definitely going to dive into that.
Yeah.
I want to ask you one more contextual question before we start on that,
Yeah.
though, which is I was thinking about this. I feel very out of date on what the state of the art of profiling is. It's a good reason to have you on the show. I remember days of, you gather logs from different machines and at least try and put them in one place and look at those. You'd find things that seemed to be a bit weird, and you'd
Yeah.
probably end up recompiling a suspected app with a minus minus profile flag that was
Yeah.
specific to that language or that compiler, and you'd slog it away from there.
Yeah.
And are we still in that state, or has the state of the art moved on from that to something better than remedial profiling?
I think we are, in a sense that we as human beings like the comfort zone. So that has been used for quite a long period of time. We have a lot of tools that are using it. And then it's just, yeah, a lot of people are still using it and didn't get out of that bubble. But on the other side, are having now a lot of tools that enable to do that in a much more modern way, in a much more continuous way. And I believe the discussion that we're going to have is more around what we call now continuous profiling. It is like how we can get this continuous feed of data, similar to what we have with metrics. So how we can get this continuous feedback about not only the health of our system, but the code that runs into our system, how we can continuously verify how the memory is used in our applications, how the CPU is behaving, not only from application holistic point of view, but also going down to the code bit and the lines of code, which method is using much CPU, which what code is basically stressing that much of my memory, what's inside my heap, where my CPU spend a lot of time. So all that answers profiling in general tries to answer. But what the shift that is happening recently is we are trying to get into that continuous collecting of that data. It comes with a lot of challenges, don't get me wrong, but it comes with a lot of benefits that we are continuously getting that feedback. We are continuously analyzing it, but not only from we are getting that dump, analyzing it, and then trying to figure it out hours, minutes, even days later. Now we are continuously seeing it when it's happened in real time, which is a big shift from where we were at in the state that you mentioned.
Okay, I was going to leave this till later in the podcast, but I
Okay,
have to bring it
sorry
up
for
now.
that. Yeah,
The idea of the idea of I see a lot of problems with the idea of continually profiling all your applications.
yeah,
And the first is that just sheer volume of data being gathered.
correct.
So if that's solved, maybe we should talk about what eBPF is and then address how it solves it, because that seems like a showstopper to me.
So it's going to be a lot of amount of data that is generated, and there is no right or wrong answer here. It just like you have to experiment with it. You have to find the best uh, use case for you, the best thresholds for you, and how you're going to benefit from the continuous profiling data. Um, so a clear sample that a lot of people like, simple rule of thumb is that the more recent the data, the more frequent we keep it, and the more historical data we make that window longer. An example is we want to keep the frequency for the last 5 minutes higher, for the last minute even more higher. Like we're getting, for example, 100 milliseconds for the last minute. We can get a second for the last 5 minutes. We can get a minute for the last hour, and then we can expand on that. So having that snapshotting will enable us to lower the amount of the data that we get, and then we process it into the server.
So
And
you're
then
saying,
go ahead.
sorry, are you saying then that like I'm thinking of a web server, like I might be able to go and see profiling data for every single function call that served a single web request
Yeah.
within the last 5 minutes. But if I come a day later, I'm just going to get like how long it took speaking to the database, how long it took to serve the whole request.
I mean, you can get the whole data for every. I mean, we capture the data based on thresholds. That's the what widely is used, and then you have a between a time span that you get a snapshot of what's happening and profiling data. So let's assume it's 100 millisecond, and then you can get the data of each 100 millisecond. But if you check it within an hour, it's a lot of data. Within a day, it's even a larger data. Within a week, it's going to be like a lot of data that you need to store. And the problem with storage is that it comes with a cost. So you can have the granularity to go with 100 millisecond a week past. That you can have, yeah, that you can do. But then it comes with a cost that you need to save that data somewhere.
Yeah,
So
yeah.
what I was talking about is it is a problem, but then there is some ways to go around it, and one of those ways is the affinity and the fidelity of the data. How much frequency you want to keep the data, so you can basically try to minimize it by keeping the fidelity higher, closer to the date that you are at, closer to the time that you are trying to look at, and then trying to condense it and minimize it as the time passes, so you can have less data, less of obviously finer view, but then you gain in terms of storage and how much you store.
Right. So does that mean how are we doing this? Are we like if I go back an hour, I'll find I've just got the average time it took to call this particular function.
Exactly. So you
Yeah,
get,
something like that.
instead of getting the 100 millisecond, you can get for that hour like each 1 second or probably 10 seconds. So we optimize for that.
Okay. Okay, then I think we need to dive into what this mechanism is so we can start to see what the kind of data we can gather is.
Yeah.
So, eBPF, I looked up the acronym for this,
Oh,
the Extended Berkeley Packet Filter. I thought that sounds like a firewall. Packet filters are firewalls, aren't they?
it is. And so for the record, I had few talks about eBPF, and I always made a joke that eBPF and BPF has nothing to do uh, between them. They are similar in the names, but the functionalities are very different.
Okay.
Um, BPF was meant to be as a way to filter network packets.
Okay.
And then the idea behind eBPF was exactly that. So we want to modernize that eBPF and then extend it. So that's where the idea comes from. It's like an extended BPF. However, it evolved way too much to become more than BPF. So the, there is no version 2.0, for example, of BPF. It's becomes way more modern, way more structured, and it's even beyond what the original intentions were. So it started as a way to optimize for networking, but then it got used into, oh, we can use the same principles for monitoring, and we can use the same principles for security. So for
Oh,
idea that you have, that you can basically offload and upload programs to the kernel that were used, that were written in the user land, it's basically unlocked a lot of potential, and most importantly in a secure way. So
right, yeah,
eBPF, it's basically a framework, a toolkit that enable you to write a program in the user land, and then it gets compiled and verified and then loaded into the kernel as it was written from the get-go from the kernel. So the kernel now can have a set of modules or
right,
micro modules, and then those modules can be not only written by the kernel developers, it can be written by everyone. So that's why this extendability, where it comes from, that we are extending the kernel, we're making it more pluggable and more modular, that we can integrate bits over it to extend its functionality. And then, of course, it's an oversimplification of what the framework does, but it's at its core, it's basically that we are writing programs that can be loaded into the kernel. Of course, it comes with a set of limitation that there is. You can write it within C or Rust because that's what the kernel supports. You can write it with Go and Python, but obviously that ends up to be C compiled to be loaded into the kernel. So the program that you write needs to follow a certain specification, because there is a step that verifies that the code that you write is actually safe to run because it's loaded to the kernel. But putting all of that aside,
mm,
the idea that probably the listeners and the viewers need to keep in mind is that eBPF is simply a way to extend the kernel, allowing us to write programs and loading into the kernels, so they are, from a kernel point of view, as they were developed from the get-go to be run in the kernel.
right. I
And
think,
this idea just unlocked a lot of potential. I mean, you
yeah,
can imagine running everything in the kernel.
okay. So my first simple question is: are they dynamically loaded? I don't have to recompile the kernel for this.
You don't have to recompile the kernel.
Good.
No.
Okay. Because you were giving me, as you were describing it, you were giving me flashbacks to compiling Linux kernels,
Oh,
and I
yeah.
don't need to
Yeah.
go there ever again. Okay. So the next two questions are: how flexible is that? I mean, we're talking about profiling, but could you write any arbitrary kernel code? And if so, what's the security model?
uh, So you can't write any arbitrarily kernel code. I mean, you can if it passes the verification step. So when you try to load the kernel to the program, there is two important steps that happens. So you write the program and then you compiles it, and then if the compiler is happy to run it into a what we call a just-in-time compilation to have a bytecode, that bytecode. So the eBPF program, you need to attach it to an attachment point, but yeah, whatever. We'll get to that later. When you try to load it to that attachment point or load it to the kernel, there is an important piece of software that is called the verifier.
Mm,
So the verifier, it does what the name says basically. It verifies that the code that you are trying to load actually is safe to run. So it verifies that you do not have access or try to access arbitrary memory. You do not try to expose bits of memory that you don't have access to. It verifies, first of all, that you have access to run the code. And then it verifies that the paths of your code end in a stable state. You can't have, for example, while true in a kernel module. That would basically stop the kernel from working, right?
yeah,
So
yeah.
it verifies that all the execution paths in your code end in a stable state. So there is an end statement and reachable statement from there. So the verifier basically does a lot of heavy lifting to ensure that the code that you write is actually safe to run and to be loaded within the kernel. Of course, here, just to make everyone aware that we are talking about the kernel. So, aside from the fact that you need to not load any third party or arbitrary code, eBPF code into your kernel, the verifier helps you with that, but it's still your responsibility to make sure that the code that you run try to load into the eBPF is actually safe to run.
Right. So just because it passes the verifier, it doesn't mean you can just blindly trust the code you've been asked to insert.
Yeah, especially if it's coming from a third party, because that's the kernel. The verifier is still continuously evolved, but as we know in software engineering, but there are bugs, and someone might have discovered that bug before the Linux community have had a patch. So someone can basically use it as a malware, or use it as to break your kernel, use it to collect data. So there's a lot of security concerns that go with it, and the best way is to basically not load a code that you do not verify into your kernel environment.
Yes, you've got to trust and verify, I guess.
Exactly.
Yeah. Okay, so you mentioned bytecode. So this is compiling to some kind of kernel virtual machine.
Yes.
Which presumably limits the footprint of the code, which is why the verifier stands a chance of working.
Exactly. Yeah.
Right. Yeah, that makes sense to me. Okay, so we are talking specifically then about kinds of eBPF program that allow you to instrument the running kernel and hence your programs.
Yeah.
How's that put together? What's it actually doing? I sort of imagine myself down in the cellars of kernel space, looking up towards where the application's running, wondering how I'm going to find it and instrument it.
So, to our high-level applications needs to call the kernel for everything.
Yeah.
For accessing the memory, for calling the CPU, spinning threads, accessing the disk, all of that. So whenever you call the kernel has visibility over that. It knows what you need. It knows what bits of code is getting executed. It has visibility over everything. So the eBPF folks, or especially the ones that are interested in profiling, said, so we have the visibility to do that. Why not simply leverage that information that we have and enhance it with some additional information? Because when the program gets executed, the kernel can see a certain program, how long in the CPU it gets used, how much memory is used, and all of that. We know that from the age of containers and even before that. So we know that we can instrument that bit.
Yeah.
So they added basically metadata into, okay, so this code is basically using that memory, and then dump it into a profiling information, because the kernel has access over everything basically. So we just like mapping, oh, this is the function that uses this amount of CPU, and then how we can collect that information, dump it into a store somewhere, either locally, some of continuous profiling do it that, or you can basically send it to a backend that does the analysis afterwards. So there are two strategies that are happening there, either in cluster or off cluster, in a dedicated environment that does the post processing.
Right. So you might have a separate analysis team running a whole cluster of things, gathering from the main network.
Yeah.
Yeah.
And that's how, for example, Datadog does it. And probably some of the cloud environment does it as well. Like they take the stuff from your environment, collect metrics from your environment, and then send it to dedicated servers that basically does the analysis and performance. So you have some sort of agents, in that case, an eBPF profiler that does that. Or one of the magic of eBPF is that you can basically share the data between the kernel and other CPU program or userland program. So what does this mean is that you collect the data, you save it in some sort of a database, which is not a database, it's just maps or eBPF maps.
Yeah, okay.
So we save it there, and then because it's managed by the kernel verifies that only that program has access to collect that data. So we're collecting the data from there, saving it in a place, and then your other program is basically running to collect that data, either analyze it.
Yeah.
Probably you want to compress that data for network traffic if you are sending it somewhere. So all that post-process or post processing just after it's there, because to not block the kernel much, we want to do the operation as fast as possible. We dump this data, and then all compression, optimization, cleaning up the data, and all of that happen in another usernet program before it's sent to the another data another cluster or server to do the most post analysis and all of that.
Right. So whilst the mechanism is completely different, it's mentally it's the same as if someone dumps their web data into Mongo for someone else to process.
Exactly.
Yeah. Okay, that makes perfect sense.
Yeah.
The one thing I'm not getting here is I'm at the kernel level. Let's say I write a Python program that has a badly written for loop and allocates way too much memory.
Yeah.
I'm at the kernel level. I see like I'm mallocing this chunk of memory over and over. How do I stitch these things together from the kernel level call to the line of Python that's badly written?
You mean how to know which
So like
line of go ahead.
the kernel, when the kernel's madly allocating memory, it doesn't know that that's because there's a for loop on line 27.
Mm-hmm.
But I want to know that as a programmer.
Yeah.
So how do I connect the dots from user space to kernel space?
I honestly don't know how that bit is actually managed, to be honest. I
Okay.
used some tools that does it. Maybe if we dive into some of those tools, we would know the answer. So how that bit is actually done. But I would imagine it's just like basically where we know when this bit is using that much of data, and then one instrumenting and enhancing it with other bits. So I just don't want to throw anything that I'm not aware of or I don't know to the audience.
Okay, but someone has crossed that up and down that Tower of Babel to the point where
all
I can
Yeah,
see
all
my
of them.
Python program and the impact of it.
Correct.
Yeah.
All the continuous profiling tools based on eBPF does that. It's basically it's one of the building blocks of having a profiler is to know which bit of code is basically using that much CPU and that much memory and all of
Okay.
that. So even the eBPF powered continuous profiling tool or profiling tool does that as well, and they manage to crack that. Okay, which bit of code is using that much data. Uh, I can imagine, because when you call basically the eBPF program, you can enhance it with the context. So that context may be enriched as well to get that data. So there's
Oh.
different bits that can be used. I can't say for sure how it's done, but for eBPF program, you have the context as well. So when we want to call an eBPF function, we have the context over what we are calling and why and all that bits that can be basically glued together in order to get that information.
Right. Yeah.
I'm not
Does
a
this
kernel developer, so that bit is a little bit nuanced to me.
it's useful to know, like, you've used this a lot. It's useful to know where the boundaries of your knowledge are and what you had to know and what you've just learned because it's interesting. So does this makes me wonder, when I'm writing a program, knowing that it's going to be instrumented, do I change my program? Can I? Should I? Must I?
No, for most of the cases, no, you don't have to, and that's one of the benefits of using an eBPF or a continuous profiling tool that doesn't lead you to rewrite your program. Some of the profiling tool would basically you need to have add when you want to profile it and why, add those bits in order to gather those information.
Hmm.
A lot of things with continuous profiling and add annotations, you don't have to do that. Especially with eBPF, you have all the information there for you. So you have the lines of code and the hierarchy of them as well, which one is called which and which one ended using blocking that much memory, that much IO, and that much CPU. So you can basically instrument your code if needed. Don't get me wrong. Sometimes it's some use cases. You might want to instrument the code base because you are not getting the bigger picture. But as those profiling tools get more rich and more widely used, they cover a lot of the use cases that we rarely now come to a use case where we have to basically instrument our code. While they offer the options, 90% of the use cases are covered. You might stumble into a 10% where you need specific data that is not covered and all of that. You might need to basically instrument your code in order to send this data to the profiler in order to be analyzed. But 95% of the use cases, it's basically covered from those continuous profiling tools. And I have to mention, it's not only eBPF. So eBPF is shiny and going into what you mentioned in the beginning, into standardizing the way we collect the data, as going making it as the universal way of basically how we want to not only profile but also monitor our application and secure them. But there are tools that use basically agents to collect this data, such as, for example, Pyroscope. They have, for each language, they have a dedicated way in order to gathering the data. So it's not only eBPF, even if it's booming within the Linux and the kernel community. There are other ways, that is, you can install small agents with a smaller footprint, obviously, into your production environment, with lower overhead to collect this data. But back to your questions, most of the cases, no, you might run into it, but yeah.
Okay. I do like the idea, if I'm understanding this correctly, of one tool that will work regardless of language or tool.
Yeah, that's the power of eBPF. In the same way, so eBPF, in the same way as the containers manage to add this layer of abstractions, so we don't care about what language you are running. We just provide us with this container abstraction format, and then we will deploy it. And build orchestration tools that basically does a lot of that. And we took it even in the era of AI because of that abstraction way of seeing things. eBPF added another layer of abstraction. As soon as you have a Linux kernel that is within a specific versions and layer, you can basically write an eBPF program that does the magic for you.
That sounds like it'd be full of lots of different ideas, but I'm going to try and stick to profiling and not drag us down a rabbit hole. Very tempting, though it is. So I guess the next question I have to ask is, what's the overhead of this? Because I have been in situations where, like, profiling everything adds like 30% to your CPU.
Yes, and it has been the issue for so long, until the beginning of 2000, where Google decided to launch a paper, or publish a paper, sorry, for how they do large-scale profiling on their end. I forgot what they called it, but they didn't call it continuous profiling, but it's something large data center provider, whatever that's name was. But Google,
I'll find it and I'll put it in the show notes by the time this is published.
Google was the first to publish a paper with a working initial version of a profiling or of a profiler used Go, I think, or pprof, something like that, and then it sets the building blocks of building a profiler, in a sense that you collect the data, there is a profiler that analyze the data, and then you would need a way to store this data and the UI to see stuff.
Yes.
So they shared that in 2000-ish, I think, and then the industry just followed the path of Google with variations over it, but it sets basically the foundations of how profiler are built. And even if you check, even the audience check now, for some of the tools, either open source or commercial, the architecture, if it's available, it's very similar to that original paper. So we all benefited from that original paper that was published by Google.
And at that stage, they must have been fairly confident that the overhead was small enough that they could run that on the entire Google infrastructure.
Yes. Correct. And then you can imagine that the paper was published in 2000 something, but it was run a few years before that in Google data centers in order
Yeah.
for it to be published. So it was definitely run years before that. And one of the advantages is the small overhead. So basically, they unlocked that bit of how they managed to collect continuous profile information with minimal overhead across all this data center. And then if Google does it at that scale, then what's stopping others of doing it? And then a lot of companies followed afterward. Meta was back known as Facebook, did Amazon and all of that, and then a lot of tools started to pop up, both open source and commercial.
Yeah, because
Uh,
when you're doing it at that kind of scale, you can't afford to wait for a problem to come along and then persuade a team to profile a specific application, right?
exactly. I mean,
Oh.
because at that scale, you have a lot of feature teams or product teams, and then one team that is dedicated for the infrastructure. Or it's going to be a big team, but still, if whenever you need something to profile, you go back to that team, ask for the dump, and then go back again. It's just like it's going to take forever, and that team will be flowed with requests. So having that as self-service, providing that information continuously to the team that's wants it, is basically has a lot of benefits, both in terms of getting the information at well fast, but also the teams can control what informations they want to get. So
Yeah.
back to the to your original question of the overhead, there is obviously an overhead. Um, it depends on the language, it depends on the runtime, it depends on the tool that you're going to use. So for eBPF programs, for the ones that are open source, at least, they claim that they have an overhead between 1 to 2%. Things like Pyroscope, Parca, Pixie, they claim that's the overhead that they have, between 1 and 2%. Generally, it's between 1 to 5%. If
Right.
you want to run it in production, and that's because of a lot of factors. How much frequent you want to collect the data, how much data you are collecting,
Hmm.
uh, how, where, and when you do your processing of the data, the compression of the data. Do you postpone it over? Do you send it to another server that basically handles it? That is obviously going to be off CPU, but it's a lot of transmission IO that is going in there.
Right.
Or you
Yeah.
want to do some pre-processing in your cluster, in your server, before sending it to another server, and that would take also from your CPU. Pixie, for example, does store some data in your cluster in memory, I think for a period of time. So that also take from your server, but it's still within a respectable and acceptable threshold. So yeah, general rule of thumb, between 1 to 5%. With eBPF programs, they claim it's less than 2%. So you can get it around 2%, which is a huge win compared to what we had previously with those heavy tools.
Yeah, yeah, yeah. I'm trying to do the kind of back of the envelope calculations in my head. Anything less than 10%, I'd be pleased with. Anything around 1%, I would be tempted to leave it continually running.
Yeah.
Right, which would
But the
make a
problem is not
yeah.
leaving it continuously running. I mean, leaving it continuously running is a feature, but then the problem is you can leave it continuously running. The problem is what you're gonna do with this amount of data. The
Yes.
problem is not getting the data, because I think that's bit is solved somehow,
Okay.
because the overhead is not that much, so we can keep it running forever. But then you can get the amount of as much information as you want. But then once you get that information, what you're going to do with it? And then back to the discussion that we started this episode with is, okay, I have this huge data. Should I keep it all? Should I pay for it? Does it make sense to me? And then there's a question of also of uh, profiling needs to be actionable. There is no sense of having all that information and just like it's overwhelming, or I don't know what to get out of the data or how to use it in my to gather any meaningful conclusions or informations. So how much data It's one question that you need to have because it comes with a cost. And then how meaningful is the data for you as well to gather actionable insights?
Yeah.
These are two important questions that anyone willing or using continuous profiling will have to ask or has to answer, basically.
Yes, it's being that's a common problem with like being able to see inside the black box, right? The first problem is
Yeah,
seeing inside, and then that creates a nice new problem. How do I deal with this
correct.
floodgate, right?
Yeah.
So tell me, do you want to tell me how we deal with the just managing the sheer volume, or should we go to the tooling that lets you make sense of it?
I think we touched upon how we can manage the sheer amount of volume. Um, some of it would be basically um, keeping the last bits, the fidelity goes less as the time span becomes larger, meaning that um, we don't care about 3 months plus data. We don't want as much granularity and fidelity within 2 months of data. We can have a medium of 1 month, and then as the time goes by, we try to shrink and limit the amount of data that we want to have, for example. So we don't keep all the information in our server, but tries to shrink it and condense it to basically lower the amount of cost. And then what do you do with the 3 months plus? Do you throw it away? Do you keep it in an archive? Same question for the month plus. Probably you don't keep it in your primary database or primary data store. You have it into a backup data store or a secondary data store that is way cheaper. So those are some techniques basically to lower the amount of cost that you have. Because in continuous profiling, because it's this continuous bit, we're generally 95% of the cases interested in the recent informations. So either what's happening now, what's actually happened in the past week or the past month. Once it goes beyond that, it becomes kind of meaningless or less useful compared to what I have now, because continuous profiling is enabling me to compare how my code is performing now or how my code is performing compared to yesterday, to the last week, what I did wrong in that time span that basically brought the performance down or up. So that's sort of questions that I'm trying to understand.
Yeah. I would think I am looking at recent data for oh no, something suddenly got slower and we're panicking. And then the older stuff is is it me or are we getting slower? Are we slower than we were
Exactly.
6 months ago, right?
Correct. Yeah.
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 Do you also get because the third question I would ask is yeah, that we've got Rust and Python in our company, and the Rust programs are faster, but are they significantly faster?
That's a good question. Um, and if you check the studies or the not the studies, what is called the benchmarks, it suggests that it's significantly faster. However, the benchmarks are basically simple codes. It is like it's basically you send a request or execute a bit of code millions of time and then you compare it. But then let's assume, for example, that's a question that think I'm a Java developer myself. So Java is slower, Rust is here,
Yeah.
but then you add feature to them both, right? So you add features to Rust, and that's because you basically won't run in productions a code that basically print hello world, does a simple thing, or execute one request. You
Yeah.
would add more and more feature to it. So as you're adding feature, basically both of them become slower and slower and slower. So Rust may be a little bit more faster as we're adding more feature to it. But then you can see that the distance between both languages or different languages is basically gonna come closer as we're adding more features, because it's the way software runs. So we're adding code to it that might make things slower as we're adding. So it's not only the runtime might be faster, but we're adding more feature to it. It's basically will make it a little bit slower, and then we we might or might not see that big of a difference in our production environment. Probably that's one of the things that continuous profiling might help with, or might not,
Yeah,
depending
yeah.
on the complexity of the code. So if we follow the benchmarks, yes, definitely Rust is faster compared to probably Go or Java. But then as we start to add more and more stuff to it, the complexity of the applications basically take up from that. And then our programs become a little bit by bit slower and slower. And that's where probably some of the enterprise languages benefit in the long run, because they are optimized for that bit. So just to say that probably the benchmarks, even if they say that a language is slower than another one, it also depends on the use case and what you're running and how you're
Yeah,
writing
yeah, of
your code
course.
and all of that. So
Of
it's like,
course.
it's not as simple as that.
If your program mostly waits for user input, then the thing you optimize is sitting behind the keyboard, right?
Exactly.
Yeah.
Exactly.
But it'd be interesting to see that kind of data and say, okay, in the real world, in our company, this is how it's actually playing out versus the benchmarks. I think
Yeah.
that'd be
Correct.
fascinating.
Yeah.
Okay,
Yeah.
so let's get into the kind of reports that you can get from one of these tools. So the tooling is a slightly separate thing from eBPF. There are analysis tools for this data.
So they are packaged as one. So when
Okay.
you use a tool, you use it as one, but the architecture is different. There are multiple components of it, but some of them are based on eBPF. So eBPF is one of the ways to gather the data. Another way is using an agent to get this data, and the third option would be to instrument your code, as I mentioned, and then
Right.
send this
Okay.
data off. And then you would have a profiler. That's the heartbeat. That's the uh,
Cool.
backbone of the profile information, the core. Um, and then we need a way to analyze the data, and then a way to see the data and visualize the data.
Mm.
So that architecture is what the Google paper backtrain again described, and what all the solutions have in common. They have bits of difference here and there, optimize things differently here and there, but they all share the same components basically.
Is there much
Uh,
to choose between them? Are we arguing over which one has prettier graphs, or?
it's not only that. How much it costs is definitely important.
Oh
How it
yes.
optimize how it optimized for the data. Is it open source or commercial? So if it's open source, how much the cost of running it? Is there support for it, especially if you're going for the enterprise world? If it's commercial, then how much I am paying for the costs, and then that cost will go how much data you want out of it. So it's not it's not how nice are the graphs I would get, but most importantly, how much data and granular the data I would get. I think that's the biggest factor. And
Okay.
they all share similar graphs. So we'd have flame graphs. So whenever we talk about profiling, flame graphs comes to mind. So they all offer flame graphs to see which bits of code is using at that amount of CPU. You can see the memory as well. You can compare between now and a period of time, or two different period of times. Um, they offer a way to filter, obviously, so we can pick CPU, memory, IO, and yeah, all sorts of stuff.
Mm. This is um, this is making me think of the Google browser console, where I can get flame graphs from my running JavaScript. It's all
Yeah,
very nice, but it will just tell me what's happening in the browser, and I want that for the entire system, right?
yeah.
Yeah,
So continuous profiling is basically that for
yeah,
your
yeah,
application or your applications.
yeah. Okay, so what kind of questions do you ask of a system like that? Are you just trying to? I mean, where do you begin? It's a bit needle in a haystack, isn't it? Are you looking for a report that says this thing is slow? Or are you waiting for someone to say web servers are a bit slow today, and then you dig in? How do you start to know what to look at?
So um, I think if a system is slow, um, you would have traces. I mean, we talked about, everyone probably knows the three pillars of observability. So we have traces, metrics, and logs. Things are
What's the
slow.
difference between traces and logs?
So logs are contextual data of of your code. So basically, you are saying code executed here. There is an error here. So you instrument your application to log stuff. Traces are basically trying to correlate the events, or correlate the journey of a request between multiple services and components. It's widely
Oh,
used in distributed applications. While logs are within a single applications, you can see the events that happen in that you added basically in your code uh, in that application, and see the path in the path of a single event or a request in your application and how it went. It helps you to understand how the request basically behaved in your application, and they are cheap. Traces try to find the correlation between in a request, and try to draw the journey of that request with multiple components. It's very useful in distributed systems and microservices architecture.
yes. So what you're saying is if my user says, I tried to create an account and it was really slow,
Yeah,
I need to somehow trace that request through the user microservice to the account registration microservice and know that those two calls on two different machines
yeah,
are one semantic thing.
exactly. So yeah,
Yes.
that for
Okay.
the user is one transactional atomic operation,
Yeah.
but while for us is like could be the gateway, it could be the accounting service, could be another service, could be the database. So the traces helps to understand where that bottleneck comes from.
Yes.
And then once you identify that bottleneck, you want to understand why this application performance slow. So then you go and check the metrics of that application and the logs of that application. So the metrics might tell you that the CPU runs higher, or there is a lot of wait time, or we're just sitting idle waiting for an IO operation, or there is memory that is consumed very high in that application, or the logs might say similar things. But then you don't know in which part of the code is actually there is this issue. And then that's where profiler came in. So if you're understanding in CPU why my application is taking slower or spinning a lot of CPUs, you can go and check the bits of code that basically does that. Might be a loop operation that is poorly performed, so it consumes a lot of CPU time and slowing everything down. And probably for the memory, there is a memory leak happening somewhere that you weren't aware of. I mean, you can
Yeah.
see it in the metrics, but you don't know what objects are or what method are basically having that leak. So it's the profiling can help you with that basically. So generally, that's the journey. So you have an error when you I mean if an error is happening, you have an error, and then you try to boil it down to where exactly this error is coming from. And
Yeah.
then once the maturity goes up, you start to onboard it as part of your um, health metrics, in a sense that you can include it as part of your post deployment routine, right? You deploy something, and then you can compare it side by side. Oh, this bit that I added, did it have a significant impact on memory, significant impact on CPU? And then you can check it a little bit even further and check, okay, you can add some alerts. I see that its CPU have thresholds. Like if the CPU is more than 10%, send me an alert. If the CPU is more than 5%, or the memory more than 5%, send me an alert. Could be a low urgency alert, just to, oh, I've noticed this, you need to be aware. And then you can throw a little bit of AI into it, and then have it more dynamic, so it analyzes the things for you. Some solutions offer that as well. And then it noticed, oh, post deployment, there is a shift in the patterns between the previous deployment and this deployment, we're noticing this kind of patterns.
Yeah, and when you've spent a whole sprint or two doing performance optimization, you want to be able to say, "Look, I made it this much faster," right?
Exactly.
You want quantifiable credit for your end of year review.
Who doesn't?
Yeah. Okay, but you've got to explain the technical details of this particular thing for me. Someone makes a request to the web server, it goes to a user registration thing.
Yeah.
How do I stitch that together? That seems to me like I would have to do some kind of code changes to be able to connect those two calls together.
You mean for the tracing?
Yeah. Like how does the tool that's constructing this trace for me know that this request over there resulted in that API call over there?
So they generally, again, modify the context. So there is the request that you make, and it generally, either for gRPC, we expand the context, or for HTTP, we add it in the headers. So there is a request ID, and there is, I forgot, is there a session ID or something else? And then we propagate. So the request ID is the one from point A to point B, and the session ID, it goes the lifetime of the request, of the whole session, basically. And then combining those two, we're able to correlate or between the session went, or the session in that case is request, went through, or probably there is span and request. So I forgot the exact namings, but that's basically how it works. So using these two fields, we're able to reconstruct the journey of the application, knowing from point E to point B to point C to point D, and also measuring that time it's spent in each and every iteration.
Right. But is that something, if I've got a web server sitting in between a database and a load balancer, right? I can imagine from what you've said that the web server would say, the load balancer is giving me this session ID. I now need to pass it on to this SQL call or something.
Yeah.
So I would have to make a code change to pass the session IDs around?
So generally, we use libraries to do that for us. So the ecosystem has evolved that you can basically, now things are embedded in most of the applications. For Spring, for example, there is Spring Sloth. I think that was the name that basically offers you that bit. I'm a Java developer, so I'm giving that. But I imagine there is equivalent things in the cloud native ecosystem as well. There is Envoy, which basically offers you a way to visualize those bits. So there's a lot of tools that basically offers you to do that. You just need to embed them in your application. So the entry point, it's aware that, oh, that's the entry point. There is no span ID or session ID or request ID. So I need to be the generator of that session or that transaction or that request, and then it just propagated over and over again until it comes back, and then it stamp it into to save the data and save the whole history, and that's it basically.
Right. Yeah. You're giving me a lot of flashbacks during this episode, but I can sort of see how like Java would be in the background attaching a thread local variable, which would then get passed to my ORM. And okay.
Correct. Yeah.
So mostly you want to arrange that it happens by magic, but presumably in some frameworks or languages, you do have to step in.
Exactly. I mean, it's not happening by magic, but if you use those frameworks, you won't even think about it. It just happens. But I think the idea is just that they stitch context information, enable them to collect that data and then gather it back and collect it and stitch the things together.
Yes. Okay.
I think Open Telemetry has support for it as well, and it's become the de facto standard when it comes to monitoring and all of that.
Right. This implies that, I mean, it's called continuous profiling as a technique, but it implies that it also has to be ubiquitous processing. You'll only get those benefits if all the machines are always profiling.
Yes, correct.
Yeah.
That's a big ask for a team, maybe. I mean, all the machines are always profiling. All obviously comes with a cost, and then we're living in an era that you pay per node or instance. So the
Mm.
more instances you have, the likelihood of you have to pay a big load of money, and that's for some might be out of capacity. So you can resume it or have it to your critical services that you know they are consuming a lot of resources, and you want to optimize those resources, or at least keep those services healthier, more performant, and you know that they bring them more value. So you want probably to invest in these, and then when it proves value, or when the um, you're having a great year, and then you can offer that luxury of generalizing it to other services. So I believe there might be trade-offs, as you mentioned, because the ideal scenario which would be to have it everywhere. Few companies have that luxury,
Mm.
so you might want to basically limit it to the critical services. Start there, and then see if it brings value. Make the team also aware of it, because it comes also with a mind shift, a mental shift from traditional profiling or the pillars of observability. It needs to be proven bringing value. So allowing that time of adaptation and culture change and all of that is also important.
Oh, yeah, because you probably need to get everyone in the organization to start buying into it.
Exactly.
Yeah.
um, we as human beings don't like changes, and it
We don't like
needs.
changes that someone else has told us we have to make.
Exactly. And even if we science prove that it brings value, we would find a way to say it's not. So allowing the time to shift that and prove value, and allowing the time for the adaptation is also needs to be taken care of, because it's the data is there, the graphs are nice, you can do whatever you want with it. But then if there is no developer that can take those insights, takes the data and turn it into an action to optimize things, to improve things, it's basically for the company is just like a cost that they might want to get rid of, because it has not proven value. So it's there's a little bit of adaptation in there, and making sure that it brings value to the developer, and then it's part of their process and continuous improvement and all of that.
Yeah. So does this mean that you are very much you're trying to when you've done it, you're trying to show like, look how easy it is to profile your application, rather than I found a problem with your application and here's the data you need to go and fix it.
um, Maybe both. Maybe it's easier to set up. It could basically it can be onboarded part of your morning routine. You just came in and then open it in a publicly accessible URL, check the stuff, and then if you find a pattern that is weird in there, go and look into it and approve your performance of the application. Or another way to get buy-in is when there is an issue, there is no great way of proving value than fixing that issue and using those tools. So it can be a mix of both strategies. You want to get buy-in that the tools is easy to use, but also you want to prove value. And if you manage to prove it when everyone hands-on something and everyone is focusing on something, then that would be a great one as well.
Yeah, yeah, yeah. Um, that makes me think of one more practical question. Can I? This is a kernel level plugin, so can I roll it out to many servers and dynamically switch it on and off?
You mean the eBPF stuff?
Yeah. So, like, if I can, I just try and put it on all my clustered servers, maybe not gathering anything, and say,
Hmm.
okay, we'll just flick the lights on for that one and take a look at that today. Is it
You can,
trivial to
yes.
switch them on and off?
It depends. I mean, trivial is just like how easy your program is to use. I mean, it can be like a configuration batch. and then you can configure the service that you don't want to not be included. It could be um, a matter of configuration, and this configuration can be centralized. So you go to one place, configure it, and this configuration is dispatched everywhere. And then the eBPF program basically read that configuration, and then if it's on, gather the data. If it's off, just ignores it. It's just also a matter of how well your program is run. And then um, talking about eBPF program in general, but with continuous profiling, I think yes, you can do something like that if you want. Just keep it running there, and if not, just turn it off. And not collecting any data and not adding any overhead for you.
I mean, maybe I can make that more specific because I get your
Okay.
general idea, but maybe if I couch it in Java-ish terms, I've got a machine that I set up earlier and I want to either
Mhm.
switch profiling on or off. Is it as
Okay.
simple as I'm going to call an nbean on that running JVM, or am I redeploying a whole Kubernetes pod with the new settings
No, you can do it in runtime.
dynamically at runtime?
Yeah,
That
you can
okay,
do it
cool.
dynamic. That's what I mentioned. The configure. It also depends on the configuration that you have in your
Okay.
program, basically, because it's a program. You can do anything with it.
Yeah, as long as you've planned ahead.
Exactly.
Yeah. Okay.
But if it's not, as you mentioned, they would need basically to redeploy it. But
Okay.
then you don't need to recompile the kernel. It just like as any program, you just need to deploy it, and then it would take care of itself.
Okay, so I can set myself up for this kind of profiling.
Yeah.
Okay, so I've got a way of doing it that seems practical, has a low enough overhead that I might set up my whole cluster to run this.
Yep.
I can see the data management problem, but you've given me some ideas about mitigating that, reporting, getting back to the developer. I see the picture. I think you need to start giving me some specific recommendations. Which tools would you pick for this strategy?
I I like Periscope because it offers best of both worlds. It has support for eBPF, but if your org for a way of another doesn't want to onboard in an eBPF journey yet, it has an agent alternative that you can use for specific languages and runtimes.
Oh, because presumably the eBPF needs root access, but the agent I can just run in user
It needs,
space.
yeah,
So
it
if I've got a
needs, yeah,
security
exactly.
team, I don't need to have that argument. Yes.
Yeah,
Okay.
exactly. So it has a bit, as I mentioned, bit of both worlds. It has this enterprise flavor into it that make it more enterprisey, and it's pleasing to that enterprise world. It tries to find shortcuts and meet you where you are rather than trying to move you to another runtime. So that's bit I like about it. And then Periscope is from Grafana, and then a lot of companies has Grafana as well. So the tooling would be based on Grafana, which is many are familiar with already.
Yeah.
From the cloud side, Datadog have their own, and then when we were at Miami, one of the speakers basically were using Datadog, and they were very happy with it. So I think from if you want something that comes with ease of use, you don't want to bother yourself about deploying it and managing it yourself. Datadog take care of that. Another two other open source tools. Parca is one. It's really good. And then my favorite, though it's still not early days, but getting there. It's Pixie. It's a CNCF project by I forgot the name again. New Relic.
New Relic.
CNCF
Oh, yeah.
by New Relic. So it's more than a continuous profiling tool. It tries to be a monitoring tool. It tries to combine profiling together with the metrics part. Um, but it's cool. It's open source, but it also offers a way to onboard it as part of New Relic. It has this New Relic flavor as well. So it's my favorite tool so far. But again, it's still a little bit early days for it, not that widely adoption yet, but it's getting there. Since it's part of CNCF project, it has a larger community, so it's improving bit by bit.
Okay. I kind of want to ask you which one you use at work, but I suspect then the Spotify legal team will dive on this podcast, so I'll leave that question entirely. I think that gives me a complete picture. Maybe I need to go and play with one of these. Where would you start if it's just out of pure curiosity? Pixie?
I would start with Pixie, yes.
Okay.
Yeah, they have a cloud version too. So you would need to install the Pixie agent on your cluster. And then they have a cloud. Last time I played with it, and they have a cloud version that basically get the data and send it to it, and you can visualize it. So yeah, Pixie would be probably the first, and then Pyroscope maybe the second, because it's it's well integrated, easy to use, and it's part of the Grafana ecosystem. So it's nicer.
Cool. I'm going to go and check those out. Mohammed, thank you very much for joining me. And I hope when you get to the end of this recording, you don't think the elapsed time was too long or too short.
It was very enjoyable.
Great.
Thank you for having me.
Thank you. Thank you, Mohammed. As always, the show notes are the place to head if you want links to anything we discussed. And before you head there, please do take a moment to like and rate this episode and maybe share it around, because it all helps other people find us. The algorithm decides that if you liked it, other people will like it, and off we go. And that helps share the knowledge, which is the whole point of this podcast. Please do make sure you're subscribed so that you can find us in time for the next episode. And until then, I've been your host, Chris Jenkins. This has been Developer Voices with Mohammed Aboullaite. Thanks for listening.